Okay, welcome. Last session for today. I'm talking a bit about advanced data types in Postgres. So, my name is Andreas Scherbaum. I live in Berlin, Germany. I'm one of the founding members of Postgres Europe, so we organize a couple conferences like FOSS and PG Day, PGConf Germany, PGConf Europe, etc., etc. If you ever have a chance, come over and join us. I'm also board of directors for Postgres Europe, so we basically are responsible for running all of these conferences. I'm working with Postgres since 97, 98, around this time, and was working a couple years for EMC, Pivotal, VMware. That's one big company. And last year I joined a company called Adjust in Berlin, and I'm head of databases there, and we have around 900, 1,000 Postgres databases running. So it's quite a lot. If you want to find the slides for this talk, I will upload them. If you just Google my name, you will most likely end up on my blog, and there's a link for my writings and talks. That's why I upload all of my talks. Okay. I have a Twitter handle, Instagram, etc., etc., so you can find me there as well. Question: anyone ever seen my previous talk about regular data types in Postgres? A couple of people should have seen it. Okay, how many of you are using more data types than before? So the average was about 4 to 5 in the past, and hopefully a couple of people learned more about data types. This is not a list of just more data types we have in Postgres. This is rather a talk about how you can actually extend Postgres and use more data types, how you can extend data types we have in Postgres, and how to use them better, and how you actually can write your own data types, because it's also possible. In the end, every data type in Postgres is just, well, an extension. If you look in the catalogs, every data type we have is there in the catalog tables. You can find all of them if you know where to look and how you piece all of the things together. What we look into today is basically arrays and JSON-B. We will look into composite types and domains, what enums can do for us, range types, and a quick example how you can extend Postgres with your own data type in the end. At any point, if you have questions, just raise your hand and we can answer your question. Well, first data type, money. Anyone ever use the money data type? Good. We tried to remove it a couple of times. It's still there. If you ever find someone saying use money, please don't. I tell you why. So it actually only holds one currency, and it comes with a currency. You cannot just remove it. There's always a currency attached to it. You cannot use it for any kind of exchange rates. That's not how it works. But the currency you have depends on your system settings. So you can basically screw up all your data, and I'll show you how it's easily possible. In the end, it all depends on the system setting here. This includes the decimal separator, which, like dollars and cents, are separated by. And if you really want to use something for money, use numeric instead of a money type. Just to give you a quick example, so here, my system is now set to Germany, DE, DU, UTF-8. If I use a comma as a decimal separator here, which is standard in Germany or in Europe, in most countries, you see I end up as having 123 euros, which is okay. That's what I wanted to do. Well, if I use a dot, I suddenly end up with 12,000 euro, because that's what they use in most of US and Canada. So if you have the same data, you end up with different values in your database. Go back, setting this to US. You see if I use a dot, I end up with $123 here. So if you export data from from euro and load data into dollars, you end up with different values by a factor of 100. Same data, different currencies, different system settings. You're screwed. Another example, so Brazilian real. Again, if I use dots here, I end up with 12,000 real. It's really not what I wanted to have. So how can you know which one you have to use, dots or commas? You don't. It depends really on which country you are. So most of Europe actually uses a comma, except a couple countries will still have a queen, so they use a dot. Most of Canada and US use a dot, except some parts of Canada will use a comma. Any other part of the world is basically not standardized. Have fun. Okay, now that we have this out of the way, let's move on to arrays. Basically, every tuple you have in Postgres can be a multidimensional array. It can be user-defined, it can be an ENUM composite type, but it cannot be a domain. You can specify dimensions in Postgres, but they are ignored, at least for arrays. A couple different ways how you can create an array, and I will show you examples. Before we had JSON in Postgres, this was basically the go-to way to group data together. Now these days, you less and less see arrays. Most people actually move to JSON. Okay, one way to define an array is using a field. Another way is to use the array constructor. Both reside in the same row in the end. You can also use curly braces and then use single quotes around your double quotes here around your data. This is basically the same result. You can select from an array. You see, if you select the entire field you have here, you get all the array values. Or you can just pick a single one. The first one actually starts with 1, defined by the SQL standard, not with 0 like in C. So if I say, okay, my brackets here, phone number, number 1, I get my first number here. Please don't try to call this number. You can find any data in your array by using the any operator. Basically, I'm just looking for this number, and you see it will find the entire array because my select still returns the entire array here. But I can do a search in it. I can have multiple dimensional arrays in any number of dimensions you want to have. Here I have 2 by 2 dimensions. You basically just stack and group them together, and then that's how it works. You can find out how many dimensions your data field has by using the array dims operator. And it tells you, okay, this is my level of arrays I have in my field. Again, you can just use square brackets to select one element out of your array here. Or you can select multiple arrays by grouping them together with a colon. I want to have field from, colon, field to, and it will return all of the fields you have. It again can tell you how many fields we have, how many levels of depths we have in our array. And it can tell you the array length. However, this is the outer length of the array. So if you want to know the inner length, you actually have to look into the array and select one of the inner fields to select the length of the inner array. Again, I can search in arrays, and I can just say, okay, select true where in my array is field number 2 equals this. I get a true back if this is actually true, or I get a false back if this is not true. No, actually, I get an empty field back. You can modify arrays, so you can just add data, delete data, whatever from arrays. We have array append and array prepend. Prepend obviously puts something on the beginning of the array, and append something at the end. And you see my result here, I have a 3 array value, and I prepend a 0 here, I append a 4 here, and I end up with the expected result. Quite easy. You can transform arrays into strings. So if you need to have this array in another form your application might want to use, using array to string, and you can specify what kind of string you want to fill in between the array elements. Dash or pipe or whatever your application can work with. Maybe a comma to get a CSV back. Or you can unnest an array, and then you get multiple rows back. Every element in your array will have one row in your result set. Good. Any questions about arrays? JSONB. Anyone here using JSONB? Why is the rest not using JSONB? Okay, in Postgres we have two JSONB types. One is called JSON. It stores the raw data as it is, and when you access the field, it will do the parsing on the fly every time you access the field. So whatever the JSON in your data is valid or not, you only find out when you read the value, when it's parsed. And we have JSONB, which stores the parsed construct in a database. So you know by the time of writing into the field, okay, I have a valid JSON construct. And of course you can do more things like, okay, we know it's JSON, we know the structure of this, so we can do things like indexes on fields, etc., etc. Whenever you're in question which one to use JSONB. Most data manipulation in JSONB is a function call, not a DML statement. So we have plenty of functions by now to manipulate JSON. Okay, we have one JSONB field here. I'm doing the same example with phone numbers here I did with arrays, now in JSON. And I put an array, again, into my JSONB field. When I select it, I again have an array here, no, I have a JSONB field here. Postgres recognizes this as a JSONB field. It's not a text field, it's JSONB still. Again, you can select specific fields out of it. Again, it starts by 1, not by 0. And what we get returned here, it's still a JSON object. So you see we have double quotes around it. It's a string, JSON string. We can actually make this a Postgres string by casting it to text. So Postgres will go and cast it to text, and I get a text back internally. If I have this query here, and if I wrap a PG type of around it, it still tells me, okay, this is a JSONB, and I cast it to text, I get a text back. Your application might not be able to work with a JSONB result, but it most likely is able to work with the text. Okay, so let's do this different now. I'm not doing my arrays in JSONB. I'm actually going in and doing NoSQL all in, one field for everything. I have one single data field JSONB, and I store everything in my JSON. I have a name field, I have a birth date, and this is actually stored as it is. So if this would be a Postgres date field, it would actually verify the field if it's the correct date, etc., etc. Right here, it's just stored as it is. So there's no parsing, no validation, no nothing. It's just text. And I have a second line here, Postgres Europe. So we started Postgres Europe back in 2008. Okay, what if I just want to find this birth date? Why do I only get one back, not two? I have two lines in it. Anyone spotted my mistake? Yeah. One is uppercase, one is lowercase. So it actually matters here, because I have different field names. One is lowercase, one is uppercase. I can extract my data and make Postgres cast it to a field, and then right here, my validation happens. And Postgres will check if it's a valid date or not. If it's not a valid date, like you just throw rubbish into it, it will actually complain here and stop doing this query. And now we actually get a proper ISO date back here. Okay, let's fix this mistake. We rename the data field. I update my address field. I remove the wrong field. I build a new object with a lowercase name here and insert my data from the uppercase field where I have my wrong field name. And now if I select my data, I have both rows lowercase. So this is all JSON manipulation basically in my data field here. We need a couple of operators and JSON functions to make this happen. But we can do it in the end. So as I said, I can do my validation on the fly here, so I cast this to a date. And now, since we have a date, we can do all the other operations we can do on date fields and date time and timestamps, etc., in Postgres. So I can actually do now minus 18 years, and I get my data back. So this one is actually old enough to, what can you do with 18 years in the US? Nothing. 16, you can drive a car, right? And own a gun. Okay. You can add new fields, because it's JSON, you can just extend it. Again, I have a JSON build object here, the same function call I used before to rename the field, and I just add a new field here, and you see I get one new field with my hobby here. In the same way you can, like before, we can also remove fields. As another version, I can use JSONB insert, which just appends new fields into my JSON object. Basically, it's the same result in the end. This here has to be JSON text, not Postgres text, because it's a JSON manipulation. I can do JSONB set to update fields, so I need to specify my field name, and again specify some JSON text here, so we have single quotes, double quotes for JSON, and I can update my hobby from databases to PostgreSQL, making it more specific. Any questions about JSON and JSONB? Composite types. It's basically one way to combine multiple fields together. We also know them as row type or record type. And you might not know it, but every time you create a table in Postgres, Postgres will also create a row type for you with the same structure as the table. And you can use this type in other operations, but most likely it's only used by Postgres internally. You can use the row type or record type almost everywhere where you can use a simple data type, in a table, as a column type, whatsoever. Let's look at a couple examples. So I talked about money before, and one of the common use cases is that you want to store some currency exchange rates. And you always have like one currency, another currency, you have a value for the exchange rate, and you have a date or a time. This always goes together. You always have these four values. It would make sense to group them together into one composite type. We could also do 4 columns, but whatever. So I have my one field here, currency. It's a SHA-3. I have another currency, so my exchange currency. I have my date and I have my value, which is a numeric. And then I can use this type, currency value I created here, as a regular column or data type in my table. So I have just one column here, but I can still access it. So I can insert some data. You can use the row operator to create your single table here. And of course, if you select it, you see you get a row back. It's a row set here. Of course, we also can select specific values out of the row set, but most likely you want to extract the entire row set because you want to work on all the data. Good. Then we have domains, which is one step further. It's a single data type. You can apply constraints to it, like not null or any kind of checks to your data type. You can add default values. You can add check constraints, etc., etc. It's maybe an underrated feature in Postgres if you know how to use it. Yes. Okay. Come again? Yeah, but if you know how to use it, it's pretty powerful. You can, as I said, apply integrity checks. Like if you have units, you can say, okay, it must fit into certain ranges. Of course, you can always add a check constraint to a column in your table, but then you have to do it in every table. If you want to use the same type in like 5 or 10 different tables, it makes sense to create a domain and have the same check on your domain type instead of applying it to every single table. One example, Postgres extension makes heavily use of this kind of stuff for SIIDs. So, give you an example. I created data type called MD5sum, and we know an MD5 checksum is always 32 characters long. So we can apply a check here. First of all, it can't be null, so not null. And we apply a check. The length must always be 32 characters. Now we are going to use this data type or this domain in our table as a regular data type. If I'm trying to insert some rubbish here, it fails and tells me, okay, this check is violated. That doesn't look like a proper MD5sum. Of course, you can still extend this. You can check, okay, it's hex value, etc., etc. So there's more possible, but gives you an idea how to use it. And if I insert a value with 32 characters length, then of course it passes and inserts data here. That's a basic example. Couple more. So of course you can change a domain. You can add and drop this not null or null. You can add more constraints to it. If you add it to a column, you can say that it's not valid until you validate all the values in the table, which gives you a way to update a table with a new column with a domain type in it, but not instantly rewrite the entire table. You can do it later on during a maintenance. And of course, all the basic things like you can rename a type and move it to a different schema and change owner, etc., etc. We will come back to this type in a moment. Enumeration type. Anyone using this? Anyone using this for gender? My other talk actually has a fall trap for you to show you why it's not a good idea. An enum is basically a list of values you can have in your column. And it's a predefined list. Yes, you can extend it, but if you know you're going to extend it all the time, please just go and use a lookup table. This is meant for a static list of values. These values are case sensitive. You can also use a domain, basically, with having a check constraint and say, okay, check in value 1, 2, 3, 4, 5, etc. Ends up the same feature. On the other hand, if you have a domain, your check can use upper and lower case to make your text case insensitive, if you need this. An enum cannot do this. Simple example, I have a data type called traffic lights. I want to store some red, yellow, greens here. I'm using this one as an example for enum and domain. And you see my enum here has lowercase, red, yellow, green. And my domain type is actually using lower value in. So I can use uppercase, lowercase, mixed case, whatever, as input values. Yes, please? The question is when I would use one of them and when the other. Depends on you. I mean, enum is easier to write in the first place because it's shorter. You just have to specify the lists. Yeah, but enum has really just a fixed limit of features, and the domain is really flexible. Enum is stored internally as OIDs. Yeah. The question was how an enum is stored. Internally, the values are stored as OID list in a table, and you basically just pick the OID in your table. Okay, now I have my table, traffic data from all of my traffic lights all around the city, and one is using the enum and one is using the domain. And you see I don't have to specify not null for the domain because it's already included in my domain type, something I can't do in enum. So I insert one row, all lowercase red, works perfectly. I insert one row, uppercase red for the enum, and you see it's failing because I have no type in my enum which can do uppercase. I insert one case of uppercase red here into my domain, and it works because I'm checking for the lowercase value in the end. And of course, I end up with having uppercase R for red into my table, if that's the use case I want. What happens if you use either one and then you go and alter, then you have to rewrite the table. If you change the data type, it's basically a rewrite in Postgres. You need to rewrite the table. Okay, another more complex example for domains. Let's say you want to check if a human is still alive. What's my definition of alive? It's basically 150 years or younger. But you don't know when this check is applied, 1800 something or today, and you don't want to change your checks all the time. So you make this dynamic. I have a data range here. We talk about ranges in a moment. A range has two values, a start value and an end value. And I use my domain and check if either my lower value is not set or if my upper value is in a certain bound between now and between the lower value and between the lower value minus 150 years. Basically, whatever I specify as my birth date, the first value, plus 150 years. If the upper value is in this range, it's valid. If not, we just bail out. So I'm using this. Okay. I insert one value just with a birth date or first value in my date range, and you see it's working because this person is still alive. There's no second date set. This works. I'm using it to set a birth date of 2021 and a death date for 1900. And it's bailing out because it's not in a range. If I use it the other way around, 1900 to 2021, I'm still inside of my 150 years, and it's working. If I extend this to 221 years, you see it's failing because it's more than 150 years. So whatever you set as a birth date, the other date has to be in 150 years plus. Again, for an enum and a domain, you have the same things like for a domain. You can change the owner, you can rename it, you can set a new schema, you can add a couple new values here, you can rename values, you can drop values, but you need to be careful that you don't use these values in your table or the drop will not work. There's a question? Can you create domains on domains? Yes, you should be able to do so, yeah, because it's just basic type. But then you apply a lot of complexity. Yes. It will follow all of the check constraints you have, yes. Okay, so we briefly mentioned range types here. Let's have a look into them. As I mentioned before, the range types have a certain range, a start and an end. It's always two values. We can have date ranges, like a start date and an end date. We can have time ranges. date and time, or just time, start time and end time. We can have integer ranges or numeric ranges. You can use this in partitioning, as example in Postgres, have partitions on certain ranges of numeric values, time values, whatsoever. One partition every month, one partition for the first 100 customers, and then one for the second 100 customers. Up to you. And of course, we can create our own range types. Create type, give it a name, and specify as range. And you have to specify what type the data type is you're going to use. So in this case, it's a floating number. And you want to specify how you can sort, how you can calculate the difference between the two values, start and end value. You can either use one of the functions Postgres provides. So for float 8, it's just an existing function. If you write your very own data type, of course, you have to provide a different function here for your data type. This also allows sorting, because Postgres knows how to figure out which of the two values is bigger in terms of order by. So we can say something like 24, 23, and 42, my new data type, please sort it. It also allows us to use indexes on our data types, on my range. So I have my table here with my new data type. I create an index on it. I insert a couple values, 1, 3, 2. You see they are not in order right here. And if I select from my table and say, okay, order by, then you see they are ordered. So Postgres knows how to order the values because I specified how Postgres can calculate the difference between values. And I can check if my index is used. So I switch off sequential scan, so I need to cheat here because I don't have enough values in my table. I do an explain on my select, and you see Postgres is using my index I created on this column, which means no matter how big my table is, it can use this one to sort a result set. Again, I can have constraints on range types. We used them before. Prime example you see quite often somewhere on the internet is book a room, like a conference room, like a hotel room, whatsoever, and make sure that you don't double book your room. How can we do this? We can use an exclude constraint. We need an extension, which is called b3gist. And now I have my reservation table here. In this case, it's hotel reservations. I have a date range with two values. Someone is staying from this date to this date. Date ranges already exist in Postgres. I have a room number. And then I want to exclude any row which has the same room number and an overlapping stay. So equal is same room, and this two ampersands here, it's overlapping stay. I'll show you a couple more examples in a moment. So Postgres will find out that you cannot double book a room for you. I have my first reservation here, 2019 9/11 to 9/13 in room 42, and 12 to 13 in room 23. So far it's fine. It's not the same room number here. And now someone else comes and wants to book room 42, and you see I have this overlapping date range here, and Postgres tells me, okay, this is conflicting. You cannot enter this line into the database because you have either the same room number or you have overlapping time ranges. There's a couple more things you can exclude on. Most common ones are probably equal, not equal, less than, greater than, and overlap. But Postgres offers a lot more. Okay. You can also find out what is my range looking like. What is my lower range here in my date type? You can see if I have my two ranges here. If I ask for the lower one, I get my 911 back. If I ask for the upper one, I get my 913 back, so the upper value of this. You can ask Postgres if either of this one is even specified. Remember, we had a couple of examples before where only one of these was specified when we had the 150 years example. So we can ask, okay, is the lower value actually set to null? Or is the upper value set? So it's not specified, so I get a true back here. We did use this function upper_inf in the 150 years example before, but I skipped over it. So if you go back in the slides, you will find it there. Okay, any questions about enums, domains, whatsoever? Do you want to create your own data type, like really your own data type? You can do this. It's a bit of work, but Postgres gives you all the ability to do this. I have a couple examples on the following slides. I will skip over them just to show you, okay, this is all possible and that's how we're doing it, but we don't need to explain all the details here. Okay, one question. Do you know how PHP, native PHP Postgres driver handles Booleans? Not PDO, no one of the others. So like this PG fetch row, if you have a Boolean field in your database, what does it give you back? It does give you text back. So the native PHP driver has no idea what data type you're using in Postgres. What does it mean if your field in Postgres is not 0 and 1, but T and F? You get a text back. And if you have something very common like if Boolean, if it's set or not, you always get true back because there's always a text in it. PHP doesn't care if you have a T or an F in it. There's something in it which makes it true. So you have an application which you want to port from, let's say, one other database to Postgres, and you have this a couple thousand places. How do you fix this? Well, you can't, you won't, because if you're trying to fix it, you have to basically test every single place where you have your Boolean compare. Well, it's many years back, but the way we fixed this, we actually created a different data type in Postgres, and we did return 0 and 1 instead of true and false, and made everything else compatible to the Boolean data type, except the output. It's not that complicated, it's just a lot of work. Basically, you need to figure out what is Postgres doing for the Boolean data type. Input, output, binary representation, sorting, indexing, etc., etc. All of this you need to know. It's about 50, 60 functions, but about 90% you can just copy from the existing Boolean data type. So what we had to do, we had to create a new output function, basically, not representing T and F, but representing 0 and 1. And of course, you have to be super user because you have to add new types, etc., etc. What you need to create a new type in Postgres is an input and an output function. And then you're good to go. That's the basics. You also want to have receive and send to have some more presentation for like backups, etc., etc. You want to have analyze functions, so analyze can run on it, and you get indexing on top. You can do comparisons, what's bigger, what's smaller, etc. But that's all nice to have. Things you don't really need. Okay. There's a Boolean in, I already defined in Postgres, so we defined the Boolean to in, using a C string as input. And I already using the existing Boolean in function from Postgres as input function. We don't have to write anything new. We just have to change a couple of things. And the same for the output function. Boolean to output, we are using Boolean as output type here. This type doesn't really exist at this point, but we can use it. And we're using existing integer to output function. So that's basically the part we changed. We are not using Boolean to out, we're using integer to out, because integer out gives us 0 and 1. Everything else is just sugar syntax. We have a receiving function, a sending function for doing backups, etc. It's all the same, so we have the Boolean functions here. We just need to define them. And then we're going to create a new type. It's called Boolean2, because we choose this name. So here we are using the new functions we have. Boolean2 in, out, receive, and send. Everything else is like the original Boolean type. Of course, we add a comment on it. And we can already start using this type at this point. We cannot use analyze on it, we cannot do sorting, but we can use the data type. Everything else we need to do is just define more functions. Like, okay, we want to do some compositions, what's lower, what's higher. We want to have a couple operators on it, like smaller and lower than and greater than, etc. What's equal, so how can we compare this? But it's basically all using the same functions we had for the Boolean type, just using our own data type. And we made everything compatible, so we can compare our Boolean type with the native Boolean type in Postgres. So whenever someone is using native Boolean, we can compare this here. So at this point, we have sorting and indexing. Now, indexing is still missing, but we have sorting. A couple more functions for indexing. A couple more operators and operator classes. And then we're basically done. Okay, let's create a table. We have our new Boolean2 data type here. We can still insert true and false, 0, 1, whatever the native Boolean type accepts, because we're using the same input function. All we changed is the output function. So we get back 0 and 1. And that's something we can use in PHP. So if you return a value 0, and you say this PHP if thingy, then it returns false on 0. Fix a couple thousand problems in like 2 hours of work. Any questions? I have to remind you that we have a party outside, and you are invited to come and join us for drinks. Any questions? Let's go have a party. See you tomorrow. Thank you.